Hello, this is Ashwin, and today we're gonna look at the tutorial video for Laboratory 1. So basically, the lab is to get familiar with the working environment of the Deter lab. So let's get started. So this is going to be the basic NS script which we are going to upload later on. So here we are starting a new simulator, and this is the TV compact TCL file, which is the source file. And now we are going to set up four nodes: node A, node B, node C, node D. So the main idea of the lab is to form a topology, a network topology with four nodes. So we have like set up a duplex link connection between node A and node B with a link loss of 0.01, and we have like established a local area network between node D, C and B. The next three set of lines is just to configure OS for each node, and then we'll get to this set of codes later. And then the last line here is that we are going to use static routing protocol. So I'm already logged in into my Deter LAB account. So let's begin a new experiment, and project and group default. So name of the experiment would be Deter LAB 1, and let's upload the basic file which had the NS script. Yeah, so that's uploaded. So if we check in swap and immediately, which means that as soon as the experiment is begun, you get to access the nodes as soon as it's done. So let's click on submit, and yeah, so yeah, it has started working. So let me put the video on pause for a while. So once the experiment is created, we get into the main screen right here. So we have a visualization tab which shows the topology of the network. So we have node A and node B connected with a full duplex link, and node B, node C and node D connected with a virtual LAN. We have also the details of the network that has been created. So here we have the virtual node info and the qualified name, which will be later used to access the node through SSH, and the physical node mapping information, as well as the virtual LAN link, virtual LAN mapping, virtual queue info, physical delay info, physical queue info, delay node switch, the event names, and the event summary. So everything is available in the details tab. And so the next step right here is to access the node. So for this we will be using Putty app, and here uh, we are gonna access the users.deterlab.net with an SSH connection in port number 22. So let's try accessing node A. Node A's qualified name is node A.deterlab1.8542. So let me log in first. Yep. So yeah, once it's logged in, we are now connected to users.deter.net, and now let's try accessing the node A. That will be SSH node to the the experiment name, which is Deter LAB 1 dot EE542. So this allows you to SSH into node AA. Let me type in S, which establishes the connection. And yep, we are now in node A. So the command has actually enabled the connection to node A. So the next part of the experiment is to modify the experiment parameters, which can be done by clicking on modify traffic shaping from the experiment options and then choosing the parameters for the link A, for the link between A and B. So let's change bandwidth to 30,000, loss to 0.5 and 0.07, and then click on save. After changing the parameters, click on save and click on the execute button. Now these changes will be reflected in the experiment, and this is evident from the visualization tab. It shows the change in parameters, whatever we have changed. You can see 35, 24 and the loss percentage as well. So that's how you change the experiment parameters. And then swapping out of the experiment can be done by clicking on the swap experiment option from the experiment menu. And now so the next part of the lab is to install a tar file in one of the nodes. So let's modify the experiments, and then there's the command for installing a tar file. So let's install the tar file node A in user site project E542 tar file directory, and the file name is r3.5.1.gz. So let's try this ns command here, and later we'll check it out using accessing putty. So let's click on modify, and let me pause the video so that the command gets executed. So yeah, it's done. So yeah, now the execution has been done. So let's head over to node A and check whether the tar file is successfully installed. So let me SSH into node A. Node A dot deter lab 1 dot E542, and yep, now we are in node A, and let's change directory to whatever directory we have installed is, which is proj slash ee542 slash tar files, and yep, so here we can find our 3.5.1 tar.gz, which means the file has been installed successfully. Now let's modify the experiment to so let's modify the experiment again. This time let's try installing an RPM file. So the command basically installs an RPM file. File name is Apache DS in this directory. So I'm gonna run that ns command. Let's click on modify, and then this might take another 2 minutes. So Yeah, yeah, it's working on it. Let me pause the video right here. So yeah, the RPM installation has been done. So let's access Node A again, and then try and verify whether the RPM file is successfully installed. Let's change directory to /prod /e542 and /rpms. So that's the directory, and we can see that the Apache DS 200M x86_64.rpm is successfully installed. So that completes the installation of RPM step. So the next step of the experiment is to automatically start an application. So right here we have the command uh, tb setnode start command. Yeah, start command node A, and in this directory we have the file allo.sh, which is a log file. So let's execute this command first and check whether the file is being created. Oh, just a second. Let me comment this. And yeah, I missed a double quote here. Should be fine. Yep, so yeah, started working with the syntax error. So let us wait for the execution to be complete. So yeah, the execution is done again. Let us go to Node A and check whether the application exists. So it's Node A, change directory to /proc/et542, and then yeah, we do see hello.sh present. Let's try opening the file, and yep, so the file does exist. The next part of the lab is to modify the topology. Is to yeah, so it is basically establishing IP routing between the nodes. So earlier we used static IP routing protocol. So now we'll try using the manual routing protocol. So NSRT manual sets up the manual routing protocol. Now we are setting up a client LAN between node B, C, and D, and then between node A and node B we are adding one more client LAN. So yeah, let's execute this code and see what changes does it bring into the topology. And it is checking for syntax errors at the moment, and yep, it has went through. Let me pause the video here and wait for it to get executed. So yeah, it is done executing. So now let's go and check the visualization tab to notice the topology change, and yeah, we can notice that the topology has changed. So LAN has been added between uh, node B and node C. LAN 0 and a client LAN has been added. So that is it for lab 1. Finally, I swap up the experiment. Pressing the swap experiment